behave. My God. Get in line for beer. It's okay. Tonight.
Have some more chairs over here.
Does everybody have seats that wants them? We can grab a couple more seats. Or they have to sit on the steps. You're on a chair. Awesome, you guys. First question of the night. That's what I thought. By the way, go Dodgers. Yes. So, for anyone that's been coming here for a while, last year we also had Analyze Boulder on Game 7. Obviously, the Cubs won. It was crazy. I made sure that no one checked their phone and didn't tell me what was going on. But apparently, you guys aren't going to check your phones tonight to see the Astros and the Dodgers, and that's fine. I'll find out later. So thank you very much for coming out to Analyze Boulder tonight. I have a leadership team that helps put this together, and that is Jennifer, who is not here, Greg, Eric, who is not here, and myself, Tony, put this together. So awesome leadership, guys. This event does not happen without Galvanize generously letting us use their space. So if Galvanize would like to make an announcement, we're going to open it up to you. He's just going to walk away with the microphone.
Hi guys, how are you? Wow. I'm going to introduce myself on the speaker. I'm like, loud enough as it is. Welcome to Galvanize, everybody. Thank you so much for coming. Woo-hoo. Yeah. Y'all, it's like the first day that it's really windy and the snow's coming. Like I can feel it in my bones. Okay, anyway. Welcome to Galvanize. I am Katie O'Block. I'm the event manager here. So I'm lucky enough to share almost every single night of the week with people like you that come to all of our meetups and share our space with us. So Galvanize, if you have not been here before, we're a learning community for technology. So we've got a co-working space that allows entrepreneurs to level up their skills through workshops and mentor hours, etc. And then we also have a coding school. So we've got web development and data science here. We just started our first data science cohort, which we're so excited about.
Right here in Boulder?
Yes, hey, right here in Boulder. There's 13 of them, and there's a handful of even women in that, which is very exciting. But they actually are just about to finish. They'll finish out in that first week of December, and you guys are all invited to see some of their capstone presentations, which is kind of like Analyze Boulder, except they've been working on their projects and their learnings for about 3 months. So if you have questions about that, you want to attend that, please let me know. It's December 5th is when their capstone presentations are. And then otherwise, please stop by if you have any questions about Galvanize, what we do here, about what I do here. If you're looking also holiday party for your company, this lovely space is open. Woo! And then also check out our cafe. We switched the menu up seasonally, so if you haven't been there before, it's really awesome. And then otherwise, always out here. You can also talk to Tristan or Amy, and they'll have any questions answered for you, or can point you in the right direction as well.
And it's not. Yay! I was going to say it's not Galvanize's fault you guys had to get carded tonight.
No.
It's a city. It's a city. And that. Oh, you're good. I'm just going to. That they have data science, and we have a lot of the people that go through the bootcamp come here to speak, but I also want to let you know that you don't have to be doing something as fancy in order to give a talk here. If you are just someone that is hanging out in Excel and doing something cool, a moment and like the cool story they've got. So, that analyzeboulder.com, do not have to be doing a neural net, okay? Okay, and I see an embarrassed face, so I know that she's going to be applying soon.
I'll just add to that, I was talking to some folks here about doing some Excel analysis.
Oh,
So I'm okay doing Excel, so you can do it.
okay. All right, tonight we have Kyle Campbell, and I've retitled his talk, Crushing Our Data Workflow. We also have Ariel. Did I say it right? Where is he? Where's Ariel? Did I say it okay? Yes! Titled, Should I Open a Bar? And then after that, we have Greg Chase, and I hope this isn't offensive, but I've renamed it I See Blindness. Offensive?
Yes.
No, it's totally offensive. I should just go home now. It's awful. I see that our jar over there by the beer looks just like this picture, and I want to say thank you very much. Keeping the beer flowing keeps new people coming by, believe it or not. I can go on and say, check this out, it's a bunch of data nerds, blah, blah, blah. And then I'll say, but there's free beer. And people say, why didn't you just lead with that? Because data's cool, that's what I've done. So for anyone that's new, go ahead and take a picture of this slide. We have a Slack channel, we have a LinkedIn group. Obviously, we're on Twitter, and you're more than welcome to tweet anything tonight. But we are all about helping people get jobs, helping people learn the skills that they want to learn, and we connect in between our face-to-face meetings right here on Slack and on LinkedIn. Go Dodgers! Right. So, this is my favorite part, and it's perfect that Richard just walked in. So I'm actually going to switch this up and start with jobs. So we want to know who's at a company that's hiring for a job. Did you hear about some cool job? It could be in data science, it could be in engineering, it could be in UX, user experience, which is where I'm at. Anything like that, and I see the brave person in the back. We're doing something a little different. I'm going to write down about your job.
Awesome. So I'll make sure this gets on the Slack channel and on Twitter. I think Thomas is actually doing it right now as I speak. I'm Jamie Paul. I'm with your local, actually national bike advocacy organization, People for Bikes, who likes bikes. Your hand, everybody did not raise your hand. I will come up and personally scold you. We are hiring a network and mapping specialist. And so we released this year a bike network analysis called BNA. So you can find the BNA in your city. Which we're using a variety of different data sources. So we're looking for someone who is good at data analytics, who is familiar with GIS, and a bunch of other technical skills. I printed out the job description because I don't know anything about this kind of stuff. So if you are interested or you know someone who may be interested, come talk to me. You have business cards, you can look at the job description. Hopefully we can put somebody to really good work right here in Boulder.
Damn, there you go. Where are some more jobs? Dean.
Hey, I work at Activision, the video game company. Our new game launches tomorrow, which is awesome. I got positions that are not in Boulder though. They'd be in San Francisco and LA doing data science at a video game studio, typically looking at things like how players play the game, figuring out how skillful they are, doing patching and stuff like that. So if you're interested in that, come talk to me later.
Saw several other hands.
While he's walking around, Lou right down the street is hiring a senior UX designer. They must be able to do a little bit of research with me.
Hi everybody, my name is Jason. I work at the National Renewable Energy Laboratory, a research facility for renewable energy. We're hiring a data scientist / data engineer. If you guys know anybody good or you're interested, come talk to me. You can also find it at www.nrel.gov.
Hi, I'm Catherine Miskin. I'm at Zeta Group, which is a local startup that I IPO'd a couple of years ago in telecommunications. And I'm hiring for several data engineering positions. So our stack right now is SQL Server, but I'm thinking I have an email master plan to migrate over to the master parallel Exadata server, which is kind of a fun. And then we're doing Tableau. And so one of my first machine learning projects is going to be creating a machine learning-based statistical engine doing data quality on our data engineering. Does that make sense?
As long as you give a talk here, it makes perfect sense.
Anyway, I'd love to hear from you.
Thanks, Catherine.
Hi everyone, I'm Albert Wavering. I'm a digital analyst at Big. We're a full-service digital agency with an office here in Boulder, but also in Northern Virginia, North Carolina. We'd love to have another data analyst, someone who's comfortable with GA, GTM, analyzing web data, presenting to clients. If that sounds interesting to you, afterwards, I'd love to talk and connect with you all. Thanks.
I'm a UX analyst. So if you know anyone who knows how to use Google Analytics data, knows how to implement Google Analytics, or knows what Firebase, Hotjar, and AppSuite are, I want to talk to you. Thanks. Okay.
Hi, my name is Laura Baker. I'm with Vail Resorts, and we are hiring in the marketing analytics department. We have 2 positions for customer analysts, for sort of the core reporting for Vail, so we take all the different business units reporting, so it's Tableau to build out of our enterprise data warehouse. Governance position open also on the marketing analytics team, and a decision support manager, which is sort of in between an analyst and the business side facing. So we have several open positions at Vail.
Laura, thank you.
Laura, I have a question. We have a few undergrad students here that are in the marketing area taking analytics courses. Are there internships available for them?
So I know that we already have a contract with someone at CU right now for internships. So there is a new one every year. I think we filled the spot for this semester, but definitely apply.
Well, the internship thing reminds me that at Zayo we have a really big internship program every year. And the positions are going to be posted here in December, and interviewing starts in the beginning of January. So it's very active. The real world projects are spread out throughout the company, so it can range from GIS to marketing to analytics to, it runs the whole spectrum. Please definitely keep an eye on that.
Greg a high five, because he picked you out really nicely tonight. What about events? Who knows about stuff coming up in the next few weeks? I'll start. You got it? Next Thursday, November 9th, we are finally bringing back World Usability Day to Colorado. It hasn't been here for a couple of years. We only have 12 tickets left, but I would love to see you guys there. It is all about inclusion and user experience, and we're going to be talking with literally 4 of the most amazing panelists ever about difference between diversity and inclusion and building products for a variety of audiences and why companies should give a shit about good user experience. And yeah, I said it.
It's a bit last minute, but on Friday is the second, I think, or third Rocky Mountain Product Camp. I'm a product manager down in Denver. I live in Boulder. It's going to be happening at Commons on Chautauqua. Afternoon starting at 12:30, 1 o'clock. 3 sessions and then a happy hour afterwards. So if you're interested in learning more about product management or if you are a product manager who has data, look it up. It's a really good time, and you don't have to be there the whole time. You can come just for 1 session for an hour. I'm probably going to do 2. I work right near there, so it's easy to get to. If you have any other questions, come see me afterwards.
I'll just announce these really quick. Solderworks is a new co-working space for makers. They're having an open house. I am co-instructing with Girl Develop It and Introduction to User Experience in Denver this Saturday. And Boulder Fit Tech is a fairly new meetup, sort of in between programming, maker, and they seem like a really cool group, so I thought I'd pimp them out. You guys ready to actually hear the talks instead of me? Yeah. Woo! All right, Kyle, you're up first. World's fastest lavalier exchange.
You can use this.
I will take my beer this
My
time.
beer's down here. Sorry, 1 second.
All right. Hi, everyone. I'm Kyle Campbell. I'm from Backflip Studios here in Boulder. We're a small mobile gaming company. I'm going to tell you about a bug up my ass I got a few months ago around workup. So basically, I don't know if you heard about it. It's called data science. People are really into it. And I think what happened with me and my company, as happened to a lot of people at other similar companies, is trying to grow up that like a data group, a data science community, all that stuff within your company, starting small and getting bigger. Basically what happened is I eventually figured out I have a pain point, it's called workflow. Basically the way it happened with me, and again, I think it happens a lot of other places, is that when I was hired, I was the only data person. I was the only data person for a few years. And so the data science, the data aspect of my company was all isolation. You know, the warehouse was me and my machine. And so I think a lot of that happens in a lot of companies, and being structured so that you can share it easily is not on the forefront of my mind when it's just me. Later on, when we started growing the team, getting on more people, and I started getting questions like, have you done this before? Do you have code for this? What's going on here? I'd have to shrug my shoulders and say, yeah, maybe, I don't know, that's over here, maybe it's not. And then recently I went over to the Pi Data conference in Seattle and realized, hey, I'm not the only one having this problem. A lot of people have had this problem before, and here are some ideas of how they solved it. So, since data science is the hot new thing, what's even the hotter thing right now is supporting data science, so that now that people grown up these teams built up around supporting data science within your company. A few examples of some that I've seen. A lot of them come from data science consulting firms that later on kind of introduced products around how they help their internal data science consultants organize and keep things structured and have full provenance. And they decided to open that up and make it actual product. I am going to be fully transparent and say so much of this was completely stolen from this blog post from Silicon Valley Data Science. Again, it's a data science consulting firm. We basically kind of did a nice write-up on how they do data science consulting, how they do workflow, how they structure things, all within. Sorry.
I'll give you 30 seconds more.
All right. And so if you just go and Google workflow data science, workflow Jupyter notebooks, that kind of thing, written articles, from this guy at a data science consulting firm to articles on kind of bigger companies that have large data science teams like Stitch Fix, and there's kind of amalgamated a bunch of them and used it for what we do. So, the key first and foremost is you want consistency and reproducibility as much as possible. And so to work through that, we have created a single repository with our analyses, with code templates, any models we produce, any tools that we use around that stuff, all in one repository. Any sort of new analysis or modeling, also Jupyter Notebook, can either be run locally or on an Amazon EC2 instance. I created documentation around the standardization of naming structures and folder structures. all that kind of thing, so that someone outside of the group can go in and navigate and kind of find things very easily. And also it's important to have full provenance of your data. You bring in a CSV, how did you get that CSV? Where did it come from? Did you have a query that got that CSV in? Is that query directly in the notebook or is it somewhere else? Tell you all the steps that got the data there. You have the Jupyter notebook to show what you did after that. And commit often. So some Jupyter notebook best practices that we've kind of tried to establish. One of the big problems with Jupyter notebooks is they don't have to be linear. You can set a value up at the top, you can set a value down at the bottom, and now that one at the top is out of date, so to speak. So it's important that you have it linear, as in you can hit restart kernel and run all, and you get the exact same results back that you had initially. There's been Stitch Fix has actually put out a specific tool that enforces linearity in Jupyter notebooks to kind of to work through this problem. Another thing we do is anything that's a big analysis, like model creation, break it out into multiple workbooks. Label them as such. So if you're making a new model, there's one notebook called Data Clean where you bring in the data and you clean it up. There's another notebook that's feature creation where you're making all your variables and such. Next notebook is training and all that stuff. So just kind of break it out in nice, easy, kind of consumable chunks. And at the top of notebooks, what are you doing here? What's your description or analysis? Do you have a hypothesis to go along with that? And again, full provenance of data is very important. Where did you get that CSV from? How did it get there? How did you find it? Or what queries did you need? What filters did you need to get it into the state it is? And then lastly, one that Silicon Valley data science suggested was to have post-save hooks, so that when you save your Jupyter notebook, the raw Python, you save a raw HTML, and you save PNG of the figures. Because if you try and do a diff, a diff in Git on Jupyter notebooks, it's kind of nonsense. And so having the raw Python there will show up. It's much easier to see the difference between your actual code if you're making changes. Here's just kind of an example of kind of the repository structure we've adopted. Product, templates, tools. We do everything with a date and initials of the person who initially did it. So it's all there in that thing. I suggest looking at it. And then lastly, is to be able to run things on EC2 when you don't want to bog down your machine or have a little extra thing. So I made a happy little script that automatically calls up on EC2 instance any size you want. You connect to it automatically. It pulls over the repository, and you can go.
Questions already? Question for the recording.
Given the troubles that Jupyter notebooks inherently cause, why use them? Why not do some things in Markdown? Just comment the heck out of the code or something like that. What advantage do you gain?
One of the advantages you gain is that, you can use Markdown. That would be I think that would be a good alternative. The other nice thing is that, a lot of times, we're producing, I'm pretty sure you do in Markdown too, you're producing graphs in line, you're producing everything else in line to show all the steps. Jupyter notebooks have just become, for better or for worse, because even despite known problems, they become kind of the gold standard. And so it's kind of one of those things where it's a familiarity thing.
More questions?
Quick one, what I have is a rat's nest. I can make run all and within the individual notebooks, but after I get 20 or 30 notebooks, and, I should have a sort of label on in terms of the general category. How do you do the top of the notebook?
So you mean you have 20 notebooks that kind of link to each other, that are kind of interconnected? Yeah, admittedly, it's one of those things where we haven't, for the most part, we haven't had anything that's that big. Like I said, model creation is usually basically 4 or 5 notebooks, things like that. And the simple, and it works when it's that small, is just simply putting like a folder, say this is step 1. data cleaning. This is step 2, feature creation, and just say 1, 2, 3, 4, 5, because at least at the very least you know which order to run it in. That first one will probably bring in data externally, do whatever we need to do, and then subsequently the data set, which will link to the next one, which will generate a data set, and so on. So that's all we do. Admittedly, we haven't hit a problem with, because we haven't had all on the same project.
Yeah, so just a quick plug for what we're talking about, but reproducible research. It's kind of more of an academic side on this, but it's very applicable to, it's really building on what you did, also going into how you actually structure your data. An entire ecosystem has been developed around this. So like, in the R side of the house, there's all kinds of packages, which like you shape your data, you mark down, all that kind of stuff, which helps you really organize this in a really effective way. So have you thought about using any of those tools? Or looked at any of that research or application?
We have not. A lot of it is because we are still quite small, and so it's one of those things where we're small enough right now where we can pivot real quick if we wanted to, and we're also small enough that to organize and to figure that stuff out, we don't get the luxury of at all, really. And so most of, admittedly, like I said, most of my research has been just looking at what other people have done, and a lot of it's been around kind of Jupyter notebooks and structuring it that way.
Do you have to keep a cattle prod handy that everyone can follow all those rules?
Like I said, we're small, so the cattle prod reaches from me to the guy behind me, and that's kind of it. So far, it hasn't been a problem. Admittedly, it's one of those things where if for some reason we do get fairly large, I'm sure there's to be some big changes.
I was curious, how do you handle the environment behind the notebook? And, how do you share that with someone else if they're trying to get ramped up?
So, admittedly, it's not something we've done yet entirely. So, one thing is that on EC2 side, so the script that calls up an EC2 instance to connect to Jupyter Notebook over there, that has a set AMI. So that AMI has the full requirement stacks, has exactly the same environment between me and anyone else. It's the local environment, so the problem.
Question and comment. Plug for our studio notebooks, the R notebooks. They handle Python code in code chunks, and they don't break Git. They play very, very nicely with Git.
Good here.
Awesome. All right, Kyle, thank you so much. Up next is Ari. He's going to tell us if we should open a bar. If we do, we need to card every one of these.
Do I use this?
We're going to equip you with all of these things. This will go in your other hand. Awesome.
Are you person? I wanted to know if I should open a bar. First, let me thank the organizers for putting this together and allowing me to give this presentation. This presentation is my capstone project for the data science immersive program. I just finished it 2 weeks ago in Denver. So let me introduce myself. Something else. I'm from Argentina. I have a PhD in physics. I've been working the last couple of years as an independent consultant. As I said, I just finished the data science immersive program at Denver. So, of course, I wanted to answer this question with data and data science. So I will start with the data. It's public data that I got from the US Census Bureau. They have a very nice website where they make their data available. It took me some time to learn how to navigate it, but the important thing is that they have this item with the code and everything that I can call a bar. So I call it a bar. So we have the problem, we have the data, now the data science to answer, help to answer this. Bars are a particular kind of business. They are very local. You cannot e-commerce the bar experience. So I have to choose locality. As you can see, I chose US counties. There are over 3,100 of them, and they vary greatly in their characteristics. Here I'm showing 3 of those characteristics, the areas, the population, and the population densities. And I want to highlight that there is no scales are log 10, so what the numbers represent are the digits of those quantities. So as you can see, all of those things span many orders of magnitude. So this is after trying different ones, the random forest regressor, the maximum depth of 6. The features are listed there on the right. Ones are population and hotels. Hotel is there as a proxy for visitors. When you go to a bar when you're at home and also when you're away. So I want to take that into account. On the left is showing the prediction by the model predicts as number of function of the actual number of bars for each county. So for instance, that lonely spot on the top has 200 bars, and according to the model, it can support up to 400. Country were to open a bar. In fact, all the counties above that 45-degree line are places where there are less bars than the model predicts. The one below that 45-degree line is where there are too many bars according to this model. So the information I wanted, basic market analysis, is there. I wanted to take it a step forward and produce also a tool easy to use to find or to retrieve that information. I chose to go with a web app where you can select the state, also the county, click on advice, and get that basic market analysis. So it tells you how many bars are according to the census bureau. Tells you a range of bars that market can support. This market, for the county seems to be 2 bars for us. So, should I open a bar? Well, there are other things that are going to answer that question, but the important thing is that it allowed me to produce this tool using a machine learning technique with public data, generates the basic market analysis, and provides it in an easy to use tool that is well known. You can go and check. That's the URL for that bar, no, for that web app, and that's the QR code. It's mobile friendly, so play with it. That's it. I have a couple of seconds.
I'm very hard to survive for a second. On your code, 7224, I think it was for bars.
Yes. Was
that specific just to establishments that serve alcohol, but does not include things like breweries? You have more than double that in breweries.
Yes, those are drinking places. So those are places that serve alcohol. No,
that's a different.
Yes. Oh, well, I didn't find it.
Maybe. Well, I'm just curious to know.
I'm going to echo him for a change. So this would be an example of the importance of metadata. Just want to say, metadata rules, and I'll do your walk for this.
What is the next?
add tax data or revenue data to your model?
That was my initial idea of having the revenue bars. Only 2 weeks to put this together. I haven't the bars. But once I have that information, it should take me. Shouldn't be that
complicated. Did any of the data take into account the idea of dry counties or anywhere in Utah?
Not yet. This is 2015. But dry counties, no, I haven't included it yet. I'm working on that. So there are things because I found that my presentation for science immersive, and I said I'm not including that presentation. I haven't included it yet.
This is, I think, almost a follow-up question. I was going to ask about it. Was there anything you learned from the outliers from the, where the model really diverged from the actual data? I can imagine dry counties would be on one side. Any kind of reason where it's looking at there may be way more bars than the model.
Basically, because I didn't look into it. Also, as part of the web app, the ranking of the best places to open bar, basically those are the outliers, the most extreme outliers. But I haven't checked what's in common, what they have in common. It's a good question. Many ways to go after this.
I think we got one more question. Do we have the mic?
Yeah. Issues with overfitting or model stability. I've had kind of some mixed results with random forest regression in the real world, especially when you're talking about new samples that you haven't observed that are beyond the 45-degree line that you project. Can you talk a little bit about how you kind of overcame some of the studies with the algorithm?
I first started saying, well, okay, I just wanted to look for outliers, so is to train my. Of course, I was getting 199. Well, I didn't feel comfortable with that, so I had a test. I separated the test sample that were like 20% of the counties, and trained the model about 80%, and the results I had there were on that 20% that I used for testing. So it didn't overfit. I had other models that you can tell that was overfit because the scores I was getting for the were much higher than testing. So yes, there is art there, and it's not optimized. This type constraint next to 2 weeks, but it's something else to analyze.
Awesome. Do you know off the top of your head what the outlier is? Awesome. So up next we have Greg Chase, and before you clap, he's going to be using this recording for a job interview, is that right? So we're supposed to be really, really nice to you and not say bad words? You get 6 questions. We'll edit those out. All right, so for posterity's sake, I want you guys to just roar with applause. Okay? Up next, we have Greg Chase.
So if you already know, I'm Greg Chase. I'm a recent graduate from the Alchemized Science program. So I've always had a very deep appreciation for medical professionals professionals and doctors and what they do, but also a really deep passion for data science. So at Galvanize, I combined those two together and created INET, which is a neural network that's designed to detect diabetic retinopathy. What it is, diabetic retinopathy is a disease that affects diabetics and them only. Any diabetic is at risk, type 1 or type 2, doesn't matter. And what happens is you see on the left-hand side, this is a healthy eye, and it looks fine, right? But if it's left untreated, the veins in your eyes actually constrict, and the product is what we know to be blindness, or the medical term, proliferative retinopathy. You see things that obviously should not be there for a healthy eye. So the question is, how do you prevent something like this? More on that in a few minutes. What I'll start tonight off with is 93 million. It's a big number, because it's the number of people that live with this disease worldwide. Now, the diagnosis process is still really long, even by 2017 standards. You have to go to your doctor, you have to get your eyes scanned. It actually analyzes and grades these images by hand. Confidentiality, you can't talk about this over the phone, you have to come in to see the results. If life happens, maybe you have to reschedule, something happens with your kid, whatever it might be, this process could take upwards of 2 weeks. And in 2017, that's not a good idea. The process that I had, I stand, but be able to use something like INET to go and classify these photos as an assistant, not as a replacement to the doctor. And we can take this entire process down from 2 weeks to a single hour, which is orders of magnitude faster than the current process. This is with a convolutional neural network. It's something that if you're not familiar with, you can actually scan the photo and analyze it the way that your human eye is actually. So the way I started this project was with data, of course. It was 35,000 images from a Kaggle competition 2 years ago, the majority of which you notice do not have any retinopathy or any degree of it. So it's a good problem to have because the majority of people screened are healthy. But as a data scientist, you have to rectify the class imbalance. And on top of that, you'll notice that there's a serious amount of variance between all of these images. But to most of you here, they probably look the same, despite them being labeled the way they are. But a neural network is so good and does its own feature engineering that it can figure out the difference between these images. It can figure out which ones are healthy or not. So the breakthrough moment came when I was training the network originally. I couldn't figure out how to get it to be better, and so I realized, well, why not just crop the image? There's a lot of black space in between this, and on the sides of the image, well, why not just remove all of that and just get the eye itself? And once you do that, it's double. And then from there, I also mirrored and rotated the images. With a lot of problems, you can't do it, but with this, you actually can. So I can augment the entire data set from 35,000 images all the way to 107,000, in part because of it being semi-symmetrical. You can actually figure out that this is the optic nerve and the macula, despite the fact that it is rotated. It's actually changed a few of the labels. Where there was any degree of retinopathy, I changed it to a 1. And if you didn't have any, I changed it to a 0. So it's a binary classifier. The architecture, for those that are technical in the room and know about this, there's 3 convolutional layers, a pooling layer, and then finally there's a dense layer and a classification layer to tell you, do you have diabetic retinopathy or not? They're fairly interesting, but what I want to focus on is recall. Because in medicine, it's better to be safe than sorry, rather be checked than not get checked and have something advanced. What I've actually done is looked at recall, and 77% in part, not only because of the image qualities you saw, they're not all symmetrical, they're not all identical, but you also notice that I didn't drop a lot of the quote-unquote bad images, which is going to be an INET 2.0. I'm ashamed to say that this actually did make it into my data set. It has since been dropped in the new data set. Future improvements are color normalization, where I can actually change more of the colors. The data is normalized going in, but if I can actually change the colors and make it look slightly more uniform, I think it would improve. The other part is to retrain INET automatically. Training images, and it can retrain itself to get better the more data it gets. So it's almost learning the way that humans learn. But in the words of Steve Jobs, there's one more thing. So the majority of you probably have smartphones in the audience. The iPhone was actually released 10 years ago. With my spare time, was a proof of concept to put iNet on iOS. You don't have to take your phone out, it's a proof of concept, it's not on the App Store, but I was actually able to do this. And anyone that's a developer can do this with an architecture called CoreML. Model in something like scikit-learn, Caffe, or Keras, it doesn't matter, you can actually put it, convert it in Python to a .ml model file, and add it into Xcode in an iOS development environment. So this is what it looks like if you were to look at it. The images are going through a pipeline in the Docker's office. You could actually predict these things on a device. It is not being predicted on the cloud. On the cloud, you put it on your device, and you have the ability to do it in the palm of your hand. But something beyond that, give it to people that need it the most, people like Doctors Without Borders or other organizations. You take it to remote areas with no cellular signal, the people that truly need it the most. So that's iNet, and I'm Greg Chase. This is my contact information. I'll take your questions now.
Thank you for the nice talk. Question about the app that how do you take such detailed pictures with a smartphone?
So how do you take photos with a smartphone? That's one of the harder parts. I mean, the phone camera is great, but you actually wouldn't need an adapter to go on top of it. I did look into it. You need it. So you would need the adapter on top of it, plus the chemicals to dilate your eye. Once you do, photos in something like Apple's Photos library and be able to process it through your device.
So the early slide you showed us, there was a low frequency for retinopathy. The early slide, there was a low frequency. And then you changed it by recoding to make it.
So the fact that I recoded the labels, that is correct. So what I chose to do for this, it's a proof of concept. The next stage would probably be to do multiple levels of that. But I recoded it in part to try and make the neural network recognize more.
Okay, so that's a very big change though, because trying to detect rare events is a problem for UV systems.
No, and it's something that is augmented with more, I would augment it with more of the data, rotate and do what you saw with only those specific categories on a higher scale. To make sure they were close to even.
Question over here.
Tendency to overfit dramatically. It was impressive that your test and your training set had about the same accuracy. That
How would I attribute it? Well, what I can actually tell you is when the network got, it was optimizing a lot of some of those hyperparameters, because as I started building network, I noticed that there were still some problems with overfitting, like what you were suggesting, the difference was maybe 20%. It was pretty bad. So I would actually attribute to the fact that the network is simple and tuning the hyperparameters. The optimizer that is used is Atom, which does have a tendency to overfit. When I tried it with other optimizers like Adagrad or stochastic gradient descent, the results were okay, but I do think that if I were to make it deeper, probably wouldn't be something like Atom. But that answers your question.
One more question?
Did you see special techniques or financial to use to tackle the data imbalances that you mentioned before? Make more equal
So if I hear your question correctly, is augmenting the data set to detect the disease?
Augmenting the data set or using more classifiers or actually sort out that I know the people from MSU, they classify now the bad ice for this case, but they actually classify the good ones with right decision. They sort them out, and then they continue that with different other classifiers, making the data more.
I thought about doing it. I thought about using different classifiers and doing it for this proof of concept I had. Like RA, it was very similar where do it. If I were to go back and actually revise it, I would most likely do it.
Awesome. Thank you so much, Greg. All right, so we have the room for another 40 minutes. We are going to drink and talk as much as we like. And because most of us are introverts, I've put up a question for us to chat about. So which came first, the job or the experience? There's a dog in my office named Chicken? That's funny.
First, the data, or the data.
So either one, but thank you guys so much for being here. Do not tell me the score of Game 7, and have a great night. Thank you.
Thank you for that.
Give a talk next time.